tugs escort big ships in and out to ensure a safe passage through the approach channel and apply steering and braking forces to a disabled vessel by escorting tugs and to keep it afloat, or limit the impact of collision or grounding if they unfortunately happen. This also reduces the risk of pollution in port areas and port approaches due to groundings or collisions caused by technical or human failures on board a ship. The escorting tugs should be able to control the ship over a relatively large speed range, let us say from 10 knots down to 0. When planning an escort and berthing, the factors to be considered should include the dimensions, draft and maneuvering particulars of the assisted vessel, the destination, transit route, passage times, planned escort speeds, and emergency anchorages, any shipping traffic and hazards along the route, the environmental conditions likely to be encountered, the size, type and bollard pull of the escorting tugs and method of escorting, the required position of tugs relative to the vessel, the maximum towline forces the escort is capable of generating at the escort speeds, the safe working load of the fairlead, bollard and/or strong point on board the ship to be escorted, the escort's tug rendezvous position, communication equipment and channels, and the requirements regarding towing equipment and towline handling. The role of the pilot is to coordinate all available assets to safely conduct the intended maneuver. These assets include the tugs, the ship's main propulsion and rudder, the ship's bridge and deck teams, the use of the mooring lines and boats to best suit the specific vessel, the berth and approaches, and the environmental factors. The desired action of one tug may simultaneously create an unavoidable or undesirable consequence which the pilot will look to counter by introducing or removing a separate force elsewhere. The role of tugmaster is to carry out the commands of the pilot providing it is safe to do so. They are responsible for the safety of their tug and their crew. If a tug is requested to carry out an action, they should do this as efficiently and as accurately as possible. Tugs frequently operate out of sight of the pilot and bridge team, as a result there is an assumption made by the pilot that the tug is operating as and where requested. Any restrictions to carrying out the action required need to be relayed to the pilot as early as possible so that they can be taken into account. Equally, any safety concerns, clearing proximity to hazards, or observations by the tugmaster are of timely interest to the conducting pilot. The pilot identifies the positions around the forward part of the ship where he wants the tug to push or make its line fast. The forward tug positions are center lead forward, port and starboard shoulders, and port and starboard main deck forward. Similarly, the pilot identifies the positions around the aft part of the ship where he wants the tug to push or make its line fast. The aft tug positions are center lead aft, port and starboard quarters, and port and starboard main deck aft. Modern ships have marks showing where the tug should push. These marks are located next to bulkheads in the assisted ship. Between these marks, the ship has fewer reinforcements, and the ship's side can be dented by the tug. Pushing tugs can also be used to alter the ship's position in a longitudinal manner whilst close to or alongside the berth. The tug can be requested to vector ahead or astern. The tug will be angled in a way that it applies the pushing force in the desired longitudinal direction as well as pushing the ship alongside. This is very effective and can negate the need for kicks on the ship's engine. However, it is not recommended with movable fenders such as tire fenders, Yokohama fenders, pole fenders, or poor condition fixed fenders. The process of tow line connection can be a particularly vulnerable period for the tug as it operates in the different pressure zones around the ship. The faster the ship is moving, the more the interaction forces will affect the directional stability and relative positioning of the tug. Slower speeds offer more reaction time for the tugmaster to respond, particularly for any tug on the bow. The tugs use their own tow lines, most are synthetic fiber rope, but some smaller tugs use wires. They are to be passed to the ship by firstly receiving a suitable, legal, heaving line which will be connected to the tug's messenger line. The messenger line can then be mechanically hauled on board the ship and used to heave the tow line on board. Manual handling of messengers and tow lines is best avoided whenever possible, particularly when connecting in open water where there is movement in a seaway. The tow line should pass through a Panama lead and be secured onto a tug strong point or suitable set of bollards. Roller leads and leads, which are scarred by wires, are to be avoided. The pilot should be informed of the safe working load of the bollards and fairleads, and this should be relayed to the tugmaster. The best combination of fairlead and bollard is preferable, close to the vessel's side and in the most direct line between them. The tug should avoid putting any weight on the line until they have been signaled by the deck crew that they are all fast. This is commonly signaled with crossed forearms. If they do not receive a visual indication from the deck, then they are to contact the pilot immediately to obtain confirmation. The recessed bit is a type of ship's towing fitting installed on the side shell of the ship. Recessed bits are normally provided to easily attach the towing lines where the height of the mooring deck is too high. Every tug connected to a moving ship is not escorting. When the tug is not imparting any force on the ship and the speed of the connected vessels is less than 6 knots, the situation is properly defined as a ship assist mode. To be truly considered escort capable, a tug must be able to safely and effectively provide steering and/or braking forces at speeds greater than 6 knots. Compared to typical ship handling tugs, escort tugs need a higher metacentric height and more freeboard to resist the expected towline forces and wave buildup associated with indirect towing operations. For stability, it is also important for the tow point, where the line leaves the staple, to be as low as possible. Potential down flooding points should be as high and inboard as possible. Size matters. Escort tugs are generally between 28 and 40 meters in length. Tugs less than 25 meters may not be able to generate high enough indirect hydrodynamic forces from their hull and keel. Tugs over 45 meters can generate very high escort forces, but may have more difficulty managing them if they are not maneuverable enough. Typically, tugs over 40 meters in length are seldom used in ship handling operations for this reason. Of course, the strength of the towing fittings on the escorted ship may also become a limiting factor with excessive escort forces. Escort tugs are equipped with a fin or skeg, which in most modern tugs is normally positioned under the bow. The fin generates most of the towing force at speeds greater than 5 knots. Direct towing is performed at low speeds, from about 0 to 5 knots. The tugboat uses the engine and propellers to generate the tow force, which is governed by the conventional bollard pull of the tug. Indirect towing is performed at speeds of in the range of 5 to 12 knots. The tugboat uses the fin forward to generate a tow force by angling the tug to the direction of tanker's heading. The attainable steering force is governed by the design of the skeg or fin and tug speed and angle of attack, but is generally 75% to 85% greater than the tug's bollard pull. When an escort tug is tethered and is following a ship, the speed is typically kept at around 10 knots and normally not more than 12 knots. At this speed, the tug would use indirect towing if the tanker needs assistance with steering. When the speed of the tanker drops to about 4 to 5 knots, it is more efficient for the escort tug to change into direct towing mode. Some of the general requirements for tethered escort tugs include good maneuverability and free running speed, good seakeeping conditions when free running as well as in the escort operating mode, sufficiently high freeboard, good static and dynamic stability, a safe working deck for handling of towlines in rough sea conditions and at high speeds, ability to apply high steering and/or braking forces over the whole escort. The tow winch should be a constant tension type with a synthetic fiber tow line of adequate capacity compatible with the design steering force of the tug. Deck equipment construction should be suitable for escort operations and be such that it can easily withstand the high towline forces. Tow lines should have a high safety factor and preferably be made of light and strong synthetic fibers with positive buoyancy to enable safe, fast, and easy handling. And good fenders, preferably all round the tug hull. Good all-round visibility from the wheelhouse and including the towing winch. A high-quality, reliable radio communication system. Openings in superstructures, deckhouses, and exposed machinery casings situated on the weather deck, which provide access to spaces below deck, should be fitted with watertight doors. These doors should be kept closed during escort operations. The pilot will instruct the tug to make fast at a location on the ship. If he anticipates, he will require the tug to pull. The pilot will ask a tethered tug to keep a slack line, or to pull at either 90 or 45 degrees, and will specify the percentage of power the tug should use. A shoulder tug which is made fast and lying alongside the ship's hull will often be able to lay back alongside and in doing so exercise a braking force. This will not generate the same braking force as a stern tug but could be sufficiently useful in the absence of a stern tug, or even in addition to a stern tug braking. Tug girting is a dangerous situation that occurs when a tugboat is pulled broadside by a towline and can't maneuver out of it. It can quickly lead to capsizing or sinking. It occurs when the tug does not have enough leverage to counter the pull of the towline. Girting the tug can be caused when the tug thrust or maneuvering lever cannot counteract the force of the tug's center of hydrodynamic pressure acting on the tug's turning lever. Girting is particularly hazardous to conventional single-screw tugs. Tractor and azimuth stern drive tugs are less likely to girt because the tugmaster can produce significant thrust in all directions to maintain the tow alignment. The conventional tug's towing point is forward of the propulsion point, which can make the tug susceptible to girting. Towing from a point near amidships on a conventional tug is inherently unstable and can result in situations where the load on the towline can heel the tug over to a large and dangerous angle. The tugboat crew must be properly trained in the causes and possibility of girting. Avoiding excessive loads and ensuring proper weight distribution can minimize the risk of overturning. Ensuring proper weight distribution can minimize the overturning moment of the towing gear and avoid excessive loads. Tug crews should develop and practice their emergency response procedure for the possibility of girting and subsequent capsize. It is crucial to have a reliable quick-release mechanism in place. This mechanism should be easily activated from both the local area and the wheelhouse to ensure a swift response in case of emergencies. Regular and competent maintenance of the equipment is vital to ensure its proper functioning. During towing operations, it is important to keep all openings closed to prevent water ingress, dangerous situation that can occur when a tugboat is towed broadside and can't maneuver out of it. This can lead to the tug flooding and capsizing. Girting happens when a towline under tension can causes the tug to heel over. The force of the towline can overcome the tug's riding lever. Towing from near amidships can make the tug unstable. Girting be prevented using a gog line, which is a fair lead system that prevents the towline from being pulled across the tug's beam. Using a gob rope system keeps the tow line low and fixed to the after end of the tug.
Using a gog or gob wire can provide additional stability and control, further enhancing the safety of tugboat operations. This arrangement should be adjusted correctly in accordance with industry standards, and often the gog wire should not exceed half the distance between the bulwarks or crash rails. In cases where a central securing point is not available, gog wires may be connected to pad eyes on both sides of the main deck aft. This can help limit the transverse movement of the towline, ensuring safer towing operations.